Okay, so again we have a modelling problem. The profit when making and selling X number of speedboats per month is given in the following table. Obtain a scatter plot of the data. Okay. Cool, looks fairly quadratic. Which model type is most likely to fit the data? Okay, well let's go ahead and calculate a quadratic. Alright, and we can see it's got a very high coefficient. How does it compare with the cubic? Okay, cubic also has very strong correlation, but we might just stick with the quadratic because it's pretty much one, and quadratics are a little bit easier for us to deal with, not as many numbers to write down. So which model type is most likely to fit the data? Yep, quadratic. Find the model of best fit. Okay, so what we have then is the profit is equal to ax squared, so we've got minus 2.14 x squared plus bx. B is 68.5, and plus c, where c is minus 238. 239 even. Okay, so this is our model for the profit. Done. Use the model to estimate the profit for the month if 0 boats are sold and if 8 boats are sold. Okay, so let's just copy our model straight into here and let's have a look at what the graph says. Okay, so 0 boats. This occurs when of course x is 0. So we might need to come down a little bit in the V window. Alright, now of course when x is 0, what's the profit going to be according to this model? Minus 239. Okay, so if 0 boats are sold, profit, or well it's a loss, is minus $239. Okay, what about if 8 boats are sold? Well, this time we're just g-solving for the value of profit when x equals 8. Okay, so we're doing a y calc when x is 8. Alright, we make a profit of $172. Now the profit here is in thousands of dollars. Alright, so it seems a bit ridiculous to make $172 profit off a boat, selling a boat. 172,000 might be a bit more realistic. Alright, but we just put our numbers down there. Explain your answer to DI. Well, if you don't sell any boats, you don't make any profit, and you make a loss because you still have to pay the people who are selling the boats. Alright, you have to pay to bring them out and display, keep them clean, that kind of stuff. Maybe even registration. How many boats should be sold to maximise the profit? Well, let's just use our graph again to find the max. Alright, x equals 15.99. How many boats is that? 16 boats. Alright, when we sell 16 boats, we have the maximum amount of profit. Check your answer by differentiating the model. So if we've got P is equal to this, then P dash, okay, is going to be, we're just finding the derivative of this. So we're going to have minus 4.28 x plus 68.5. So we've differentiated the model, and remember, the maximum point occurs when the derivative is equal to 0. So let's make this equal to 0 and solve for x. So we're going to have minus 4.28 x equals minus 68.5. We just divide both sides by minus 4.28. So what's our answer? 68.25. 68.5 divided by 4.28. Alright, 16. Okay, so again we've proved that the maximum occurs when we make 16 boats. Give a possible reason for why the curve decreases for larger production. Okay, so why is it in our graph that when, I'll bring the graph up here, as the number of boats being sold, are we talking about sold? As the number of boats being sold increases, why would the profit decrease? Why would the profit decrease when the number of boats being sold increases? Alright, I'll let you have a think about that one. And for what level of production does a loss occur? Well, you make a loss when you make more than how many boats? Let's see. When you make more than 28 boats. Okay? For some reason, when you make more than 28 boats, you make a loss. Cool.